Hello everyone, I am Ayush Singh. Today I will be sharing my project work on PhonePay dataset. So the outline of a project will be first the problem statement, knowing our dataset, exploration and understanding a dataset. Then we will move to some visualizations. After that we will perform SQL queries and we will then deploy it on Streamlit. So the problem statement. So with the increasing reliance on digital payment systems like PhonePay, understanding the dynamics of transactions, user engagements, and insurance-related data is very crucial for improving services and targeting the users effectively. So the aim of this project is to analyze and visualize the aggregated values of payment categories, create maps for total values at state and district levels, and identify top performing states, districts, and pin codes. So let's try to understand a bit about our data set. So this PhonePay Pulse dataset. So basically, the PhonePay started in 2016 and has been a strong beneficiary of the API-driven digitization of payments in India. When PhonePay started, they were constantly looking for definite data sources on digital payments in India, and they will definitely fail on that. And so, on the hope of giving back to the data and developer community, PhonePay decided to open the anonymized aggregate datasets that demystify what, why, and how the digital payments in India work. And it is licensed under CDLA Permission 2.2 Open Data License. And this PhonePay Pulse dataset, which is open source, it is the first of its kind data initiative in the payment space in India. So the goal, the goal of dataset is to share with everyone, so they can understand, have insights, and visualize how digital payments actually work in India in the past 5 to 6 years. So basically, this is the guide for dataset. Our entire dataset has been structured into three parts: aggregated, map, and top. In aggregated, we have aggregated values of various payment categories, such as which will be shown in category section. And the map is total values at state and district levels, and top is a total of top states, districts, and pin codes. So let's try to explore the dataset. So basically, there was a GitHub folder of Pulse where we can find the dataset. So here we can see there are three folders of aggregated, map, and top. If you look at the aggregated, it is divided into three subclasses: insurance, transaction, user. So let's try to look over aggregated insurance. So there was a bit confusion. We'll try to look into it. You will see that it is like in a different way of representation, like insurance slash country slash India. Actually, these all three are directories. So if you'll just try to confirm it, we'll, let's say path we have chosen as Pulse, then we went to data, we went to aggregate, then insurance. Now to check that what will the directory inside it, it came country. Because this is like a sequential top to bottom. Okay, so basically then I try to load this a single JSON file. This is a very single JSON file. So my first intuition was to, okay, I am very well familiar with the pandas, so just let's convert it to data frame. So, but we are not successful in that. So later on, I tried to like work in it as like a dictionary. So and that was very effective. So I opened this as like JSON.loadf data.keys. I got all the keys. Then I went to data. I got check the keys. I went. I tried to understand like where actually was data stored. Then I went to transaction data for zeroth index. Then we got in this form. Then I went to payment instrument and again zero. Then we got the type key, count key, and amount. And we were mostly interested into count and amount. This is the we actually was trying to this for different samples. So this is basically for Delhi 2023, Jammu and Kashmir for 2024, just to verify that what I'm actually doing is correct. So later on, I basically looked over the entire folder, entire directory of insurance, and stored it in a form of data frame. It was stored in the clean section. Oh, clean aggregate insurance.csv. So this was my data frame after compiling the entire JSON files. So here you can see we have the state, we have the year, we have the quarters 1, 2, 3, 4, we have the count and the amount. The features we were mostly interested into. So the same I did for aggregated transaction and again for aggregated users. The same method was replicated for the other two categories. Like aggregator, we have map. We also had map and top. I used the exactly same method, like treated it as a dictionary and try to find the keys and the values in which data was actually stored. So if we try to look over the map insurance, if we go for the keys of data and again data, we'll see that the column name were latitude, longitude, metric, and label, and the actual data was stored in the data key. So if you are aware of this, we can easily find out, make the loop and store the values. Similarly for map transaction and for the map users, same way top insurance, top transactions. Basically in top, basically I divided in two parts. For district and pin code, I made two separate CSVs. So actually, if we try to look over this JSON file, we will see we have the district keys and later on we will have pin codes. Basically, this is the top districts and the top pin codes. Sorry. So this is the merging of the entire data set. We have different data was basically scattered. We were basically trying to integrate it into a data frame. So these are all the data frames which I formed using these JSON files. After I went for visualizations, so this was the mean insurance count by state. The states are kept in descending order, and the mean insurance amount by the state. This is mean insurance amount, and this is mean insurance count, and this is mean insurance count by the year. We can see there is a gradual increase, and by 22, 23, 24, 22, we can see a very sharp increase. Initially, it takes time to obviously introduce a new concepts in the market, and the mean insurance amount by the year. This is also a very sharp increase with time. This is the total transaction amount by the type year wise. So if you try just look at peer-to-peer payments was maximum and also kept on increasing. Like if you try to see the gap in initial years and after the later recent years, the gap actually widened. Okay, so basically this is the cleaning part. Uh, and after that we have the SQL queries. So if you just try to open the workbench, so here basically I loaded the tables and basically I performed the aggregations here. So let me just try to run this. We have our aggregated insurance. After that, I grouped by state and took an average of count and amount, and also ordered by the average amount in descending. This was our data set, and I did the same but with respect to year. So here we can see like the actual thing of find out the Karnataka has the highest average amount, and if you try to look at by the year, so we can see like in the recent year like 2024 23, the average amount is basically way larger than the previous years, and this is by the quarters. So okay, so we can see there is a different trend in quarters obviously because there are many factors. Maybe there were maybe festivals or many other factors which were influencing this. And if you try to look for aggregated users, so this is our entire data frame. If you try to look keeping grouping by the brand, because this is important to understand, like so we can see that the Xiaomi brand, the average percentage of selling basically opening apps was 0.26, and this is basically highest, and second highest was Samsung, Vivo. So we can easily check out the top performing brands or the payment channels from using these SQL queries. So later on we can move to the like dashboard, Streamlit dashboard part. So this is the code for that. I won't be explaining this part. So let me just, so I have already run this, and okay, this is basically the dashboard part. So here we can choose our datasets from this list. Let me just select map insurance. So basically Okay, we are getting an error here. Yeah, okay, we have the map users. Maybe there will be, I will check it again. So the total count is and total amount, the records we have. So this is the actual data frame for which selected. Let me change the year. 2020 will get for 2020. We can change the quarter too. So basically, this is a kind of filter. We can select the data frame we want to display, and also we can make charts out for that. Okay, so let me do state versus amount. So this is the plot for state versus amount. And similarly, we have the EDA plots. Also, the SQL case studies we did before. Aggregated insurance by quarter, aggregated insurance by state, aggregated insurance by year, aggregated transaction by the transaction methods, and by the brand, aggregated users by the brand. Here you can see the top performing brands and the transaction methods, which state was having the highest average insurance. And this is the geo visualization part. So here we can see, like, from the coordinates we got in the map insurance dataset, we can basically visualize that in which part of India the transactions or insurance are higher. And this is our insights, actionable insights for this PhonePay project. So we can boost our user engagement in low metric districts through targeted campaigns. From the map user CSV and map transaction, it's clear that some districts uh, consistently show lower user activity and transaction volume over multiple quarters. So basically, we can launch specific offers for our referral programs in these underperforming districts and use local language to push notification and festive discounts to drive adoption in tier 2 and tier 3 cities, and promote insurance offerings in low penetration regions. So we can bundle micro insurance products with the popular transaction categories like mobile recharge or utility payments. We can create educational content or mini campaigns that explains benefits of digital insurance to first time buyers. So here we are focusing on the low metric regions, and now we'll focus on the high growth states, like the top performing ones. So the state like Maharashtra, Karnataka, UP constantly show high volumes of user engagement. So we'll try to make it like more better. So we can increase the server capacity, app optimization for peak hours and high load states. Like we can optimize our coding sites and launch premium and loyalty programs for the power users to improve retention. Capitalize on quarterly users spikes with feature promotions. Like certain quarters like Q3 and Q2 show spikes in transaction metric, likely tied to the festivals or seasonal purchases. We can align new features, rollouts, and marketing efforts with the quarters that have historically high engagement. We can run flash cashback events or quiz-based offers during these periods to drive the repeat users. And last, by using the geodata to personalize user experience. So we have the geodata based on the latitude, longitude, and label. We can offer the beta insights and into a district level or like pin code level behavior. And we can use this to make personalized dashboards inside the Foreman app based on the user's location and highlight the local merchants, offer services to make the app feel more community centric or customer centric. Okay, that's all for this project. Thank you.